one of these for confidence intervals as well, just so you could distinguish and see kind of, the similarities when I use these terms like test statistic, what in the world does that mean? The more times you review this, the more times you watch the videos related to this section, the more you'll pick up every single time, because it's probably a new topic to you. It's abstract. The logic that we use to make the decision is not something that we experience a lot in our everyday reasoning. So here's the difference between the two sections, and the procedures are very different yet very similar for both. So we have the textbook sections. These are the two. Hypotheses. This is for a single population proportion or a single population mean. For proportions, I just arbitrarily put this number in here, but it's got to be a decimal number somewhere between 0 and 1. And whatever number there goes there is also going to go there. We don't want to use p hats here. We want to use only the p's. The claim can go in either. For the alternative, really depends upon what the claim was. And you're going to use one of these three signs. That's consistent over here with means as well. But if a claim is made about a population mean, then we have to use the corresponding population mean variable. Again, I arbitrarily chose a number. Maybe this is the number of work hours or something. The average number of work hours is 43. And again, the claim can go in one or the other. I've identified this number here as P0 because it's in a proportion problem, and I've identified this number as mu0. We'll need that number because it's used to calculate our test statistic in each case. And so we really have to enter in that number when we're going to use the calculator function to calculate this test statistic. We normally don't use these two formulas here because we have a calculator function that will calculate them for us. But just so you know, these two are both z-scores. And it tells us, we know if a z-score or a t-score gets beyond 2, that means it's more than 2 standard deviations in the mean, away from the mean or the proportion. And that usually means that we're in one of the top 5% or the most extreme 5% of the samples. And when we're in the most extreme 5% of the samples, we will tend to reject the null hypothesis. You saw this formula first for proportions in section 8.2. You saw this formula for the first time in section 8.1. And we calculated some probabilities based on this number. And the probabilities that we calculated back then were, in fact, what we now call the p-value. All right, so a t test statistic will correspond to a t distribution. And in this case, you can see the summary stats that you need to use here. You need to identify mu0, it's in the null hypothesis, and then the summary statistics. All three of these will be needed in order to plug in there to calculate your test statistic. That's why the calculator function asks for these things. Over here, you have to find P0. Well, that's in the null hypothesis. Q0 is 1 minus that. And then usually we have X and N here because together P hat is X over N. So the calculator function, instead of asking you for a P hat value, they ask you for the X and the N, and then they calculate the P hat value. But this is known as a test statistic, and this is the first output when you run one of those calculator functions. We always want to know what that number is. The distribution that we use, since this is a z test statistic, we're going to use the z distribution. That's the normal distribution. Over here, this bell-shaped distribution, the t distribution, looks very similar to the z distribution. In fact, if n gets larger than 30, it becomes more and more closely similar to the z distribution. This is helpful if you want to find critical values. All right, and now the calculator function. There's a different one for proportions and means. The calculator function that we use for proportions, 1 prop z test and its partner. If we wanted to find a confidence interval for a proportion, we would use 1 prop z int. So confidence intervals, you'll see either int or interval, and hypothesis tests, you'll see either test, or you'll see test, and usually it's the whole word spelled out. For one prop z-test, you need to specify p0 and x and n, and then the p0, this tells you something about the null hypothesis. And this last row here tells you something about the alternative hypothesis. And so you have to specify one of these, this one, or this one, or this one. And you can only select one, and that's based on the sign up here in the alternative hypothesis. Sometimes students will get these confused, and it'll be a proportion problem, and they'll use the t-test. Well, the t-test is not relevant to a proportion where a claim, or a problem where a claim is made about a proportion. And you should recognize this right away, because it's going to ask you for, mu0. You might get confused and write p0 there. But then it's going to ask you for x bar. You might confuse x bar with this x over here. That happens sometimes. But then students usually, when they get to the standard deviation, they're wondering, hey, the problem didn't give me a standard deviation. What am I supposed to do? Well, you're supposed to go back and actually use the correct function, because nowhere in here for a proportion for qualitative data is a standard deviation requested or given in the problem. Now the output from this function is just going to be the test statistic and the p-value. It might also say something about the alternative hypothesis, and it'll always report the p-hat. It's going to take your x and divide by n, and then output this. Over here, again, in addition to saying something about the alternative hypothesis up at the top, it's going to always report your test statistic and the p-value. And it'll also report the sample mean. Now, you might think that's strange, because you actually inputted the sample mean, and so it's just going to output the same thing. Where this is more important is if you select the data option and you put all the raw data in L1, then you would not know the sample mean at that point. The calculator will go into your list and calculate x bar, s, x, and n, and put them in the appropriate spot. So if you use a list, you wouldn't know what the sample mean is. And so if they report it, then that would be useful information. Step 4 is making the decision using the p-value. So since the calculator function calculates the p-value for us, either here or here, we can base our decision to reject the null hypothesis or not based on the value of that p-value. And if the p-value is less than the alpha value, this is the level of significance, then we reject. Otherwise, we fail to reject. And then step 5 is to interpret in context.